In this course, we will see the configuration of PAgP of these options. On this network diagram, we have two switches, switch A and B, which are connected together by two links. We are going to group together the two interfaces of each switch. That is to say, the physical interfaces FA0/1 and FA0/2 to force only one logical link. To begin with, we will go into the interface configuration with the command interface FA0/1 to create a channel group. We will choose channel group number 1. If we do a channel group 1 mode, followed by a question mark, we can see the different possible modes of the PAgP and LACP protocols. For example, we will take the desirable mode of the PAgP protocol, and we will also do it on the FA0/2 port. Switch A is therefore configured in desirable of the PAgP protocol. That is to say, it will negotiate with switch B to set up an ether channel. And on switch B, we choose mode auto so that they will respond well to the request of switch A to become an ether channel. A log message on the CLI confirms the creation of the port channel 1 interface. Now that the port channel 1 is created, we can enter the interface configuration with the command interface port channel. Any modification made on the logical interface port channel 1 will be carried over to the physical interfaces FA0/1 and FA0/2. We will choose 802.1q encapsulation with the command switchPortTrunkEncapsulation.1q and mount the interface in trunk with the command switchPortModeTrunk. The command switchPortTrunkEncapsulation.1q, which allows us to use 802.1q instead of the old ISL protocol, only exists on old generation Cisco switches. Today, the 802.1q protocol is enabled by default, and this command no longer exists on most devices. This is why if you configure an ether channel on Packet Tracer, you will certainly not see it. The show Etherchannel command is used to check whether the port channel is active or not. We can also see the protocol used. Here it is PAgP, as well as the interfaces used on the channel port. Here they are the interfaces FA0/1 and 0/2. The show Etherchannels summary command is very useful when you have multiple Etherchannel interfaces. It gives us a quick overview of all the Etherchannels to create, as well as the interfaces used. The third method to verify the Etherchannel configuration is the show interface Etherchannel command. This command displays information on the local switch, but also on the opposite switch. Here from switch A, we can see interface 0/2 of switch B. The configuration of LACP is similar to PAgP. You just need to indicate the LACP modes you want to configure on the ports. As a reminder, the default mode, auto, of PAgP corresponds to the passive mode of LACP, which is also its default mode. Desirable mode corresponds to active mode, and the mode on remains the mode on. You just keep in mind that PAgP can be used only between Cisco devices, while LACP is an IEEE standard, which means that it can be used to create channels ports with other providers' devices. The last thing to see about link aggregation is load balancing. The show Etherchannel load balance command allows you to see the default configuration. Here, the load balancing is done by the source MAC address. If we use the command port channel load balance, followed by a question mark, this allows us to see the different load balancing configuration possibilities. Selection can be by source or destination IP address, MAC source or destination address, or a combination of source and destination. In the diagram, we have 4 PCs, 2 switches, and 1 router. We have seen that the default load balancing is based on the MAC address. This means that all traffic from an MAC address will be sent to a single physical interface. For example, the MAC address in 3A will be sent to the FA0/1 interface of switch A. The MAC address in 3B will be sent on the 0/2, the 3C to 0/1 of the same switch, and the 3D MAC address will be sent to the 0/2 interface of switch A. As there are several PCs, this configuration is very good, because the 2 physical links between the 2 switches are used. On the other hand, on the switch B side, it's a different story, because as the selection is made on the source MAC address, router and switch B, the return path, or any other package that wants to join the PCs, will only be done on a single link, as there is only one MAC source address. The MAC addresses in 3E. It will choose either FA0/1 or FA0/2, and the other will not be used at all. This is why it would be better to change this mechanism to the MAC destination address instead of the source. In this way, the load will be well distributed on the different links, because the PCs all have a different MAC address.